So let's start some basic factoring. So first we're going to start out with GCF, which you all said stood for? Good. So we look for the greatest common factor that we have, which means the biggest thing that will go into every single term. So our first example here is 4x squared plus 20x minus 12. Now I like to start with the coefficients or the numbers first. What's the biggest number that goes into 4, 20, and 12? 4. So for GCF, you don't have to write down this extra work, but I like to go through and divide that GCF out. But what we're actually going to do is put it in front of some parentheses, and then we divide it out to see what's left, because it's the opposite of multiplication. Do I need to put a variable with this 4? No, because not all terms have a variable. That's correct. All right, so let's divide each term by 4, and we get x squared. Very good. Now, to make sure that you have the biggest GCF, there are two things that you can do. First, double check the GCF of your parenthesis. What's inside here? Does anything go into all 3 terms that are left? No. You could take the 4 that's in front and distribute it. If you did, would you get the original problem? Yes, you would. So that's 2 things that you want to do on every GCF problem. All right, let's do our second problem. 9n squared minus 24n. What's the GCF there? 3 will go into everything, and both of these have a variable, right? 3n would be our GCF. With variables, you want to pick the smallest exponent as the GCF, so n to the first or just n. All right, what is 9n squared divided by 3n? 3n, and then on this one we'd have minus 8. Do I need an n with this 8? No. Remember, if there's a power over a power, you subtract. And so n over n cancels out as well. Look inside your parenthesis. What's the GCF of what's inside the parenthesis? 1. If I distributed back, would I get the same thing? Yes. All right, problem 3. 9x squared plus 3x minus 18. 3. 3 will go into every term. Do I need to say 3x? No, just 3. Divide everything by 3. What's left? 3x squared minus x minus 6. Oh, y'all's is plus. Oops, I wrote mine down wrong. Doo-doo-doo. Now it's a plus. Now it's a plus. I'm sorry, typo there on the board. Now it matches with the worksheet. All right, what about problem 4? 7p squared plus 7p? 7p. What goes inside my parenthesis? P plus 1. That's right. You got to have the plus 1 there, because if you distributed back, you need to make sure that you get the original. So some people try to leave off the plus 1, but if you distributed, that would only give you the 7p squared. You also need the plus 1. There's a few things that I need you to know about GCF. So first thing you need to know, if the first term is negative, y'all cut out the extra chatter. If the first term is negative, you must factor out a negative. So if the first term is negative, you must factor out a negative. But that's the only time that you do that. So, for example, if this first term was negative 7p squared, we would factor out a negative 7p here. And then if you had to factor that out, that would change this sign from positive to negative. But we only do that if the first term is negative. To help you find GCF, You can also use your calculator. So let me show you where that part is. You might have remembered this from math 2, but if you didn't, that's okay. If you click math and go over to, well, somewhere, hold on, is it in there? Maybe it's under math. Oh, there we go. Yeah, over to number and then down to option 9. Thanks, y'all saw it before I did. So math, right arrow to number, and then down to option 9. GCD is the same thing as GCF, but you can only use 2 positive numbers. So you type in the first one, like 125, comma, 25. So use the comma that's above the 7, and it'll give you the GCF or GCD for greatest common denominator. But math, right arrow to number, and it's option 9. All right, let's talk about our next set of problems, which is difference of squares. Here's the equation for difference of squares. It says if you have something like a squared minus b squared, that factors to a plus b, a minus b. So if you have something like x squared minus 64, like that first problem, it's going to factor into 2 parentheses, one with a plus, one with a minus. And we basically take the squareds off. Because what times what is x squared? X times x. What times what is 64? 8 and 8. So plus in one, minus in the other. Then we can use that shortcut. And I know Xavier was talking about the shortcut when he did his homework. Remember how we just multiplied these a minute ago? And I said the shortcut was take the last 2 numbers and add them together. What's 8 plus negative 8? 0, right? It cancels out. So that's why there's no middle term. And then what's 8 times negative 8? Negative 64. Okay, let's try problem 6, the 4x squared minus 49. Now this one has a number in front, but we still do it the same way. It is a difference of squares. What is the word squares referring to? Perfect squares or square roots. What's the square root of 4? 2. What's the square root of 49? 7. So this would factor to 2x plus 7 and 2x minus 7. 2 times 2 makes 4. 7 times 7 makes 49. Remember doing these back in math too? Okay. All right, next one, x squared plus 9. Now remember our key word here is, what does the word difference mean? Subtract. So can I factor this? No, this one can't be factored anymore. And the key reason there is because it has a addition instead of a subtraction. So it has to be subtraction there in the middle in order to factor. All right, let's look at problem 8. 2x squared minus 8. Well, we have the subtraction, but what do you notice about these numbers? They're not perfect squares. But what's the first thing that we did on this page? GCF. Does this have a GCF? Yes. Always look for that GCF first. This one has a GCF, so we can take out a 2, and we're left with x squared minus 4. That's right. We could divide each term by 2. We're left with x squared minus 4. And then look at your x squared minus 4. Is that a difference of squares? Yes, it is. This would factor to what? What times what makes x squared? X plus 2 and minus 2. So there may be some problems that you have for homework on this where you actually need to factor twice, and pulling out that GCF will definitely help you with factoring twice there. So take that GCF out and then factor again. All right, let's look at question 9. So there's a lot of things going on in this one. The first thing that I notice is those are some awful big numbers. And I don't know about you, I'm not exactly sure how to find the GCF of those, but we can use our handy dandy calculator. So let's go to math, right arrow, option 9. I got my 3600 and then my 784. In Math 3, you're going to notice some bigger numbers that pop up, okay? So make sure that you know how to use that calculator to help you out. So what's the GCF with those two numbers? So let's divide both of those numbers by 16 and put what's left. So what's 3600 divided by 16? 225 minus what's 784 divided by 16? 49. Now let me show you another calculator trick to help you out here. These need to be difference of squares. Remember, your calculator will make a list of squares for you if you go to and type in what? There you go. So if you forget, go to y equals, type in x squared, then we go where? Second graph to go to our table, and we're looking for 225, so scroll down a little bit. Oh, the square root of 225 is 15. It's right there in that box. So 15 makes 225, and what makes 49? 7. Now, when you write this one, you have to write it in the correct spot. 225 is first, so 15 goes first. Plus and minus. And then 7x would go at the end. So don't flip these. Keep them in the same order. You could square root the first number. So here is an alternate way to do this problem because 3600 is a perfect square. So what is the square root of 3600? 60? Okay. What about 784? 28. So this is 60 and 28. But what do you notice about those parentheses? Are they simplified as much as possible? Because they have a what? A greatest common factor. What goes into 60 and 28? 4. 4 will actually go into both of them. So if you write this as a final answer, it's not quite done because each of those parentheses has a GCF, and we could take a GCF out. So this parenthesis we would have to take out a 4, and this parenthesis we would also take out a 4. Well, 60 divided by 4 is 15. 28 divided by 4 is 7. So in both cases, we get our 15 and our 7, but we have this 4 and this 4. And we have to multiply those two together, and we get 16. So this way is actually a little bit longer. So what's the first thing we need to do every time? Good. So maybe put a big star at the top of your paper and put GCF first. Always look for that first. All right, we're finish up the rest of these notes tomorrow, but on the back, you guys could actually do the first 12 problems if you wanted to because they are GCF and difference of squares, and we'll talk more about them tomorrow.